All right, let's download some lidar data from Utah's Automated Geographic Reference Center, and this is what I'm always referring to as the Utah AGRC. So you can just skip right into the elevation link if you want to save a step. It's a little bit confusing. At the top they have the 3-dep NED, the National Elevation Data Set data. The LiDAR comes second, and then down at the bottom they have the autocorrelated DEMs. These are at the bottom because they're the most suspicious, most filled with error data. That doesn't mean that the LiDAR is that way and that's why it's second, but these should be at the bottom because you should reference these as little as humanly possible. Okay, so I have you guys go into, I suggest anyway, a 2-meter LiDAR data set. It's labeled 1 meter here, but what we're looking for is the 2006 Wasatch Front stuff. You can go in here and pull anything you want. I don't care. You can pull 1/2 meter from the Great Salt Lake. You can go in and excuse me, pull any data that you want. You just need to make sure that your 5 meter and your 10 meter data overlaps the exact same spatial extent so that you can make a side-by-side comparison of the same area. So this is just going to walk through pulling the 2 meter data from the Big Cottonwood Canyon. You can see it switches here to 2 meter LiDAR. There are some other options down here. But this is just the easiest way to do it, is to use the web application, the 2 meter Bare Earth. It brings you to an interactive map. So I just double click on this guy until I can see Big Cottonwood Canyon, which is this guy. Cottonwood Heights is at the kind of head of it, or the mouth of the canyon. And then you just want to pull 2 tiles that are adjacent to each other and that cover some portion of the watershed. Like you could see in the instructions, there's 51 tiles. There are 51 tiles that cover the whole watershed, and you could do that if you wanted to or / needed to. But for our purposes, I'm just going to cut you guys some slack and have you download 2 tiles. So you can either freehand draw a polygon, which is this tool, or you can try and use some of these tools instead. I just think this is the easiest. I'm going to draw a fairly constrained little circle and just see what we end up with. This is kind of covering a ridge line here. Solitude Mountain is here, Brighton Ski Resort, Alta. But the watershed boundary is here, so if you're going to work in Big Cottonwood Canyon, stick to the north of this southern ridgeline. Okay, so over here we have been moved to the 3rd step, which is the LiDAR DEMs. If you drop down the 2 meter, it gives you the option to pick Bare Earth, which means they've cleaned off the vegetation and cars and buildings. All the first excuse me, all the first return stuff has been cleaned off, and now what we have is just a Bare Earth model. This is the raw XYZ data. It's going to give you first return, and you'll get vegetation and any other structures that might bounce a signal back. So we're going to expand the Bare Earth and then hit download. And it just moves us to step 4. You're not actually downloading anything yet. But you can see here that even my small little polygon generated overlap or an intersection with 8 different tiles. And so you can hover here and see which ones they are and just pick 2 that are adjacent. Maybe these 2 would be a good move, or if you want to deal with the valley floor, or you could pick maybe these 2 adjacent. It doesn't really matter, but you're going to want to just get 2 that are adjacent that have something that looks somewhat interesting. What are these 2 down here? So maybe I'll pull these 2 guys. And so I'm just going to left click. I just left clicked on that hyperlink and showed you what happens if you left click. This isn't true for all browsers. It's different depending on whether you're using Firefox or Chrome or Internet Explorer. I'm using Chrome. So you don't want to do a left click. This opens up the raw table that shows you what a raster data set looks like in its ASCII kind of text format. It tells you that in that tile there are 1,000 rows and 1,000 columns. It gives you the coordinates for the X lower left and the Y coordinate of the lower left corner, and it tells you that the cell size is 2. We know it's meters. And so this actually allows you, you could just get graph paper out and you could draw this thing out yourself. It's telling you, okay, starting in the lower left-hand corner and reading across, this is the elevation for the first cell, this is the elevation for the second cell, and you're going to go over 1,000 values. So it's going to populate the empty raster until you hit 1,000, and then it's going to pop to the second line. It's just going to keep going, and this is just a massive list of numbers. Where you have no data, I'm not sure how this file handles no data. Because it's a square tile, it probably doesn't have to deal with that, but oh here, sorry, it says it right here that a no data cell would be given 9999 negative. Okay, so you can go back, but you get to start all over. That's why you don't want to left click, but we all do it all the time because every browser is different. So just redrawing our polygon, see what we come up with. 2 meter, bare earth, download, here's a list. I'm going to zoom out a little bit. And let's stick with these two. So that is this guy and this guy. So I'm going to right click on the ASCII hyperlink and save the link as. And I'm going to just tell it where I want it to go. I'm going to throw it right on my desktop. And then we want, that was this one, and now I want this one. Save the link as. Notice it's downloading here. Put it on my desktop. Okay. Then I'm going to open Arc and test these guys out. Okay, in ArcMap, I've just navigated to my desktop, and here are the files. You get a text file along with a raster or grid file, and those are the ones you want to add. So I'm using the Control key and selecting both of those. And they should draw, next to each other, and we should see what looks like an elevation model. You are going to get a warning that says that the data aren't spatially referenced, so they don't have an associated coordinate system, but that's okay. We're going to fix that next. But here you can see that there's a big stitch, a big line or border between the two tiles. That's fine, but you can still see the ridge line continues up. We just have a discontinuous look because the color ramps are being applied to the range of values in each data set. We have to stitch these together, and you're going to do that using a tool called Mosaic to New Raster. And while you do that stitching, you can also assign the coordinate system to this data so that it can draw properly. But this is basically where we're going to stop in the download process. You can go in and look at the properties of these. Just to verify, you want to look and see that you've got an appropriate range of values for each one, and in meters for this part of the country, that makes good sense. Under the Source tab, we see that we've got columns and rows. There's 1,000 of them. We knew that. The cell size is 2 meters. And then for the Mosaic to New Raster, you're going to need to make note of the pixel type and the source. So it's a 32-bit float. Oh, sorry, the pixel type and depth. And then you need to know how many bands there are, and there should just be one because it's a black and white. And then the cell size. Those are the things that you need to fill out the Mosaic to New Raster form. And then just be aware that it doesn't have a coordinate system, but it soon will. Okay, so that's where we'll stop. If you have a question about downloading data from the AGRC, let me know. Thanks.